Today we are going to learn about up and down counter. Right? In a single program, we will design up counter as well as down counter. So screen is already shared. So let's check out what are the parameters and which are the lines, input and output lines for up down counter. For example, we are going to design 8-bit counter. So obviously we'll have 8 input lines and we'll have the 8 output lines, not the input lines. That we will have 8 output lines, and we are going to make it up as well as down counter. So for that we'll have to use one controlling parameter, and we will call it mode. This is the mode line, right? And this is the output line, और हम उसे बोलेंगे this is count. हम उसे define करेंगे as a count 0 and is count 7, right? So 0 to 7th number, right, of a count 7 down to 0, right? So these all are your outputs. And so on. So we are going to design 8-bit counter. We will design it in such a way that if mode is equals to 1, then it is up counter, right? And if mode is equals to 0, we will design a down counter. Again, we will have 2 more lines. One is, you can say, this is the 2 input lines, and one line is known as the load line, which is the input line. So when the value of load is equals to 1, right, at that time your output will be loaded with some predefined value, right? So you can input it with some predefined input value, you can say D in, right? So for that we are also giving one more line, it is D in, D underscore in, whose size is again 7 down to 0, right? So when the load is equals to 1, output count 7 down to 0 will be equals to D 7 down to 0, right? Output will be equals to input D in. It will be loaded with the predefined value which is saved in D in. If we are using one more line which is clear. So if the value of clear is 1, then all the count lines will be set to 0. Right, all the outputs will be set to 0. If clear is equals to 1, all the outputs will be set to 0. And obviously we'll need a clock. So this is the clock line. At every positive edge of the clock, our output will be either up counted or down counted. Just a second. right? So at every positive edge of the clock, your output will be either up or down depending on the mode selected. So let's start with, is it clear how to make the counter? New project, and let's give the name
Yes,
as
ma'am.
up underscore, or I'm just writing it to be counter, up down counter. Next is verilog, next finish. Okay, so the project is created. We are adding a new source which is verilog module. Again the same name, counter. Next, now which are the inputs? The input will be mode, clear, load, clock, and okay. So these are the 1-bit inputs, while let's say DIN input line. So this is the bus type of input जिसका MSB है, it is 7. We are defining it to be 7. Next and finish. Okay. So yet output is left to right. So here I will write output reg. I will have to define it as a reg because हमें previous value remember करनी है. So 7 down to 0 और हम उसे नाम दे रहे हैं count. Okay, fine. Now we will write the body of the program. Always at pose edge of the clock, positive edge of the clock, लोड पिन प्रायोरिटी हमने किसको दी है? लोड पिन को दी है, राइट? सो इफ लोड पिन इज 1, then count will always be equals to DN, right? See, here we have used non-blocking assignment because at every clock pulse we'll have to change this value. If else if clear is equals to 1. See, जब हमें equals to 1 करना है तब हम नहीं लिखे तो भी चलेगा, but if we want to equate it with 0, that if we want to check it whether the condition clear equals to 0 or there, so at that time we will have to write clear equals to 0, right? But if we want to just check the condition of 1, then there is no need to write clear equals to 1, right? It just means when we are writing if clear, it just means that it is clear equals to 1. If clear is equals to 1, you can say count is equals to 0. Else if mode, now we will have to check out the mode. Mode is equals to 1. Mode अगर 1 है, then count should be incremented by 1. That means count plus 1. Else final count should be decremented by 1, minus 1. Right? And AND module is already provided. So I am just saving it. So now let's start the test bench. So new source, new verilog test fixture. Give it the name to be TB underscore counter. Next, finish. So test bench is generated. Now you can see all the inputs are defined as reg and only count is defined as wire. So here I am removing the test bench what is provided over here, or yeah. Before that, we will initialize the clock pulse. That initially the value of clock should be equal to 0. वो 0 से start होगा. 1 dash B 0. Now let's define the clock. So we will write always at start and #5. Every 5 time unit, clock should be changed to inverse of clock. And now we will write the test bench. We'll write the test bench to be mode equals to 0, clear equals to 0, load equals to 0, and D in is equals to 0. Now let's, as the D in is actually a 8-bit data, right? So we will have to write it as to be 8 dash B. अभी हमें यहाँ पे 8-bit डेटा देना है. Let's say it is 0 0 0 0 0 1. That means we are starting from 1, right? We are starting from 1. So अगर लोड है, लोड की पिन अगर 1 है, then your output should be 1. After 5 time units, now let's change all these values. अब यहाँ पे हमने सबसे पहले प्रायोरिटी किसको दी थी? काउंट लोड को दी थी, उसके बाद क्लियर मोड, राइट? सो हम यहाँ पे उसी तरह से चेंज लाते रहते हैं कि इफ द वैल्यू ऑफ लोड इज 1, और यू कैन ऑल्सो चेंज इट योर वे. अगर हमने यहाँ पे क्लियर को 1 कर दिया, फॉर एग्जाम्पल कंट्रोल C कंट्रोल V, यहाँ पे हम क्लियर को 0 करते हैं. ओके, यहाँ पे लोड इज इक्वल्स टू 0, लोड इज इक्वल्स टू 0. नाउ हियर क्लियर को हम 0 करते हैं और लोड को वी आर सेटिंग इट टू 1. कंट्रोल C. नाउ लोड को भी हम 0 करते हैं, क्लियर को भी 0 करते हैं, और मोड को हम सेट करते हैं एज 1. And we are not supposed to give the clock over here because clock will be changing. Right? Fine. And after 100 time units, we'll have to end the simulation. So I will write and finish. So this initial will be ended over here. One initial block. इस initial block में आप देख सकते हो कि only one line is there. That's why there is no need of begin and end. Same way यहाँ पे always block है. Always block में भी सिर्फ एक ही line है. So there is no need to use begin and end keyword. So as I have told you in last laboratory session, that all these initial, always and initial, all these 3 procedural assignment will start concurrently at the 0 time units, right? All these will start at the 0 time units. But उसके अंदर जो lines हैं, those lines will be executed sequentially. Every procedural assignment starts at the same time, time equals to 0. Initial, always an initial. So I'm just saving it, and let me just check for the syntax. So syntax error is not there. So now let's simulate the behavior. Now see, यहाँ पे हमने mode की value 1 रखी थी. That means it will become the up counter. We'll have to wait till it takes some time. ओके, यहाँ तक समझ में आ गया सबको?
यस मैम।
ओके, सो okay, fine. Now you can see here कि at 0 time units यहाँ पे हमने काउंट में कुछ भी नहीं रखा था, राइट? देन और हमने क्या बोला था कि हमने क्लॉक की वैल्यू इनिशियली 0 की थी, एंड इन द प्रोग्राम वी हैव रिटन ये काउंटर डॉट वी में वी हैव सेड दैट एट एवरी पॉजिटिव एज ऑफ द क्लॉक, तो जब भी क्लॉक की पॉजिटिव एज आएगी तभी हमारी वैल्यूज चेंज होगी एज पर द लोड, क्लियर एंड मोड वैल्यूज. सो यू कैन सी हियर कि यहाँ पे क्लॉक की वैल्यू 0 है, सो विल नॉट गेट द एनी आउटपुट काउंट. एट द नेक्स्ट लाइन यू कैन सी कि यहाँ पे हमारी क्लॉक की पॉजिटिव एज आ रही है. वी हैव इनिशियलाइज डी एट 1. द वैल्यू ऑफ क्लियर is 0, the value of mode is 0, and the value of load is 1, and so your output count will be loaded with d in. So as the value of d in is 1, your output will be 1, right? Then after, at the next point, we can see that we have changed the values of load and clear to 0. यहाँ पे हमने लोड एंड क्लियर की वैल्यू 0 कर दी है, राइट? एंड सो जब भी ये नेक्स्ट पॉजिटिव एज ऑफ द क्लॉक विल कम एट दिस पॉइंट यहाँ पे, राइट? सो एट द टाइम व्हाट विल हैपन, एज मोड इक्वल्स टू 1 इट विल बी अप काउंटेड, राइट? इसकी वैल्यू क्या है, क्या हो जाएगी? इट विल बी अप काउंटर. इट विल बी डिजाइंड एज द अप काउंटर. सो 1 2 3 4 5 6 and so on, right? And this will continue up to 100 nanosecond. Our simulation will be ended at 100 nanosecond. So I think, is it clear?
Yes, ma'am.
Okay,
यस मैम।
fine. So अगर हम इसे close करके, now let's change the values of TB counter as like हम यहाँ पे इनिशियलाइजेशन है वो हाई पे रख देते हैं 118 and we are setting the mode to 0, right? Now what should happen? Our counter should be down counter. So let's save it and simulate the behavioral model. In last laboratory session of last video, you can see in that कि हमने without test bench किस तरह से हम forcefully change कर सकते हैं variables की value. Okay. Now you can see here. I'm minimizing. Okay. So now you see our count is set to, पहले हमने क्या वैल्यू दी थी यहाँ पे लोड की वैल्यू 1 थी. So when the value of load was equals to 1, at that time your output was loaded with predefined value of d in. So d count will be equals to d in. In the next clock pulse, the load and clear both are at the 0 position, and that's why our output will be decremented. At every step, our output will be decremented by 1. Right? So if we are increasing the value, if we can increase the time for the simulation, let's say 500, and I am saving it and make it to be relaunched. And you can see we have a simulation up to 510 nanosecond, right? So this is how at every 1 clock pulse our output will be decremented by 1. Yet there is some more time कि जब अब अगर हमें 000 all लाना है, then we'll have to simulate it till next, I think, near about 500 nanoseconds. Okay, fine. So now let's check out what the synthesizer does when we have made a counter like this in a behavioral style of modeling. So let's check out the RTL schematic. Okay, so this is the counter. Whatever we have done here, the same thing will be generated by the synthesizer. Now let's check out what is there inside it. So you can see यहाँ पे this kind of design the synthesizer will implement on the FPGA. Okay, again you can see what is all these things. Okay, fine. So if we want to check out the technology schematic, then we'll go for the view technology schematic. Okay, add, create schematic. So this is the technology schematic. Double click on it and you can watch what are the uh, components the synthesizer has taken to design a counter, right? So you can see what is the complexity कि हमने उसे नहीं बोला था कि आपको क्या क्या यूज करना है synthesizer को. Synthesizer has taken itself, the software has taken all these things itself. Got it? So here the XOR gates, it has taken the count 0, count 1 and so on. Here the AND gates are taken, then lookup tables are there, right? So this is the technology schematic. And finally all the data will be stored in the output buffer, and from the output buffer they will be given to the output line count, right? So हमने एक छोटा सा प्रोग्राम लिखा है, but the synthesizer has done its task and designed that much of thing. When you are going to implement or when you are going to download this program on the FPGA board, at that time it will make something like this on the FPGA chip. If you want to check out the general design utilities, and in design summary, you can see here that number of slice register used are 8, number of lookup tables used are 11, FF lookup table and flip flop की जो pair हैं they are used as 8, bonded IOBs are 20, and this one, and you can see कितना utilization हमने किया है, right? So I think this is clear how to make a counter in Verilog, how to simulate it, and what does this counter program mean to the synthesizer, right? Yes or no?
Yes, ma'am.
Okay, समझ में आ रहा है प्रोग्राम?
Yes, ma'am.
Yes,
Okay,
ma'am.
Yes, ma'am.
okay, fine. So I'm just stopping the recording.